Hello there, my name is Rudy B. Harrising, and today I'm going to talk to you about regression. What is regression? Well, regression seeks to define the relationship between two or more variables in a more precise manner using some kind of equation. And what we're going to do today actually is focus in on what we call linear regression between two variables, looking to see if there's a straight line relationship between two variables. So let's just take an example. Suppose I was to go to across campus and survey 5 students and ask them 2 questions. First question is, how many hours do you spend on Twitter a week, and what's your GPA? And I got the following results. One student said they spent 5 hours a week on Twitter, and I got a GPA 2.0. One student spent 4 hours, GPA 2.0. One student 2 hours, 3.0. 1 hour, 3.5. And one student didn't spend any time on Twitter. They don't even have an account, and they had a 4.0 GPA. So I want to see if there's a relationship between these two sets of data. And it looks like there is a relationship, but I only have 5 pairs of data. When we have a relationship between these sets of data, we call that a correlation. So that idea of correlation, that means there's 2 sets of data or paired data, there's a relationship. What type of correlation is still to be determined, but it looks like there's a correlation. Now if I had 100 pairs of data, that would be harder to see visually just looking at the numbers. So I may want to graph the data. So it's a good idea to always graph your data in what we call a scatter plot. And what a scatter plot does is that you see each value here has what we call an x and y coordinate. And it's our job actually to decide what is going to be x and what's going to be y. Generally in a scatter plot, we want x to be what we call the explanatory variable and y to be the response. In other words, I'm trying to see if the amount of hours people spend on Twitter explains their GPA, or you can think of it as, is the GPA a response to the number of hours on Twitter? So I'm going to define this here is x and this is y. So let's go ahead and graph this data on the xy coordinate plane. So here's our scatter plot of the data. On the x-axis we have hours on Twitter, on the y-axis the GPA, and we have our points 5, 2, 4, 2, like 5, 2, 4, 2, and then 2, 3, 1, 3.5, 0, 4, right here. Okay, and we can visually see now that there is some kind of relationship between these two variables, and it looks like what we call negative correlation. So it looks like what we call negative correlation. And what does negative correlation mean? In other words, as one variable goes up, as the hours on Twitter go up, the GPA is dropping. So it's a negative relationship. One goes up, the other goes down. Okay. In math, we like to define something a little bit more formally than just visualizing it. And so we can generate what's called a correlation coefficient. And we call that R. And that correlation coefficient goes between -1 and 1. If R is close to -1, it's a strong negative correlation, like what we have here. We're going to see the R value in a minute. And if R is close to 1, it's a strong positive correlation. It means that as one variable is going up, the other is going up too. So an example of that would be like an environmental issue, like CO2 levels are rising, and the world mean temperature seems to be rising too. So that would be positive correlation. But in this case, it's negative correlation. Software can show us that this correlation coefficient R for this particular relationship is -0.98. Now when I say software, I mean like Excel and the graphing calculator will show us that. But we will see at the end of the video there's a calculation to get this number. Alright? By the way, I forgot to mention, if R is close to 0, it means there's no real linear correlation between these two variables. So that's also possible. Now, once we get the correlation coefficient, which we have, -0.98, we also like to formalize some kind of equation for the relationship between this data. And we say it looks like a negative linear relationship. Well, what's that equation? Well, that's when we involve regression. And in this case, we're going to find a linear regression equation. So software, again, will show us that the linear regression equation for this line is, we're going to call this y hat equal negative 0.42x plus 3.92. In other words, the GPA is equal to negative 0.42 times the hours on Twitter plus 3.92. And in the dotted line, you see a graph of this actual equation here. A few things to notice. The equation, the line doesn't go through all of the points. But what it is the best fitting line. And sometimes we call that the least squares regression, what we just did. And what does that mean, the least squares? It means these distances between the points, which is the actual values, and the predicted values from our line are minimized. The square of those distances are minimized. So that's why sometimes it's called least squares regression. Regardless, this is our regression equation. And what's the purpose of having the regression equation? Well, it allows us to predict things. So for example, if this relationship were true, and we'll talk about it in a minute, but if this were a true relationship here, in other words, these hours on Twitter were affecting GPA, if I said, well, let's predict the GPA of someone who spends 3 hours a week on Twitter, well, then we would calculate y hat of 3, and we plug it into our equation, and we'd get y hat of 3 is negative 0.42 times 3 plus 3.92. We plug that into our equation and calculate that out to get 2.66. And so we would predict that person spending 3 hours a week on Twitter is going to have a GPA of 2.66. Now, be careful. We just said if this relationship were true. Many times when you see a correlation between two variables, it doesn't mean there's actual something going on there. There's some kind of causation. So it doesn't necessarily mean that the hours on Twitter may be causing a lower GPA. Maybe there's something else. So correlation doesn't necessarily mean causation. So just remember that, be careful. Even though we calculate these things, there has to be an extensive scientific study to really see if some kind of causation is going on here. But just think about it. Wouldn't it be nice to be able to predict things based on data? And that's what we do in regression. We take data, we see if there's a relationship, if there's a correlation, and we generate an equation for it. And then many studies are done to see if there's actually a causation. And if there is a causation, we can actually pretty confidently say things about if this happens, this is going to happen. And so we're able to predict things quite accurately on many occasions. So that's the idea of regression. That's the whole purpose of regression. Being able to formalize a relationship using an equation and then predict things, say something. Now, how do you calculate this R and how do you calculate y hat? Well, that's a different story, and so let's look at that.